All right, so here's the topic 1 review we've been working on in class. I promised you if you had any questions, you could message me on SB to see how they worked. What I've decided to go ahead and do is do them all. And that's just because I've had a lot of students also messaging me that they want to apologize for waiting so long to reach out for additional help. So I think one nice thing that I could do for everyone is go ahead and do the whole review in a video so that you can revisit it, check your notes from what we did in class, and then just have this as an extra resource before we take our test this next class meeting. So for number 1, I have if dm equals 35, what is the value of r? So I'm going to start by identifying the information that was given to me in my hypothesis here, the if part. If dm is equal to 35, so we're going to assume that's true. And that just means if I start at D and I walk along this line until I arrive at M, I'll have walked 35 units. But I don't know what the units are, so we can just call it 35. And it's asking me ultimately what is the value of R. So just for my note, I'm going to write it up here that that's my goal, is to find a value for R. Now if I look at this, I can see that line segment DG is equal to R plus 5. And I can see that 3R minus 14 is equal to GM. Now DG starts at D and ends at G, and then GM picks up right where DG left off and continues to M. So if I were to look at this overall, I can use the segment addition postulate because these start, the orange section ends where the blue one begins. And if I add these two expressions together, I'll have traced the entire length. So that's what I'm going to do here. And just to make it a little easier to see, we're going to say that my red area is equal to my blue area plus my orange area. And I'm just doing this again to accentuate it visually, because a lot of people have been giving me really positive feedback on that. So this is my segment addition postulate set up. Here I have DG, here I have GM, and here I will be able to find DM. And when I write it this way, you can see that they can be added together, and these would drop out to make my new line segment DM, which is part of our goal. If I can set all three of these up, I can then solve for R. So what I'm going to do is take my orange area and substitute it in. I'm going to take my 3R minus 14, that's my blue section. And then these two together is equal to the red section. And now I'm going to switch back to the green ink because I am doing the algebra part now, which will result in finding the value of R. So just so that it's all color matched, we'll do that. Here I have R plus 3R, which will give me 4R. And then here I have 5 plus negative 14, which is going to be negative 9. And nothing has changed here, so I'm just going to bring it down. Now I'm going to add 9 to both sides. And then I'm going to divide both sides by 4. If I do this, 4 divided by 4 is 1, so I'm left with R. And 44 divided by 4 is 11. I can verify that 11 is an answer choice. I can also go back and verify that I've done this correctly by taking my DG plus my 3R minus 14 and seeing if they do equal 35. Let me do that in colors again. So I'm going to take this section here, and I'm going to add to it the blue section. And I should get what I've defined my red to be, which was 35. Section is off because we're checking it. Now, you guys don't have to check it, that's fine, but I think it's a good habit to get into. So now I'm going to take these values and substitute in R. So I know R is 11. So when I bring this down, I'll have 11 plus 5 plus 3 times 11 minus 14. And if we've done this right for R, we'll get 35. So I'm going to start by checking for parentheses. There's nothing inside the parentheses that I can do. Next would be exponents. I have no exponents. Now I'm going to go from left to right and look for multiplication and division. Plus, plus, here I have multiply, so I'm going to perform that operation. 3 times 11 becomes 33. I'm just going to copy everything down. Now I can do addition and subtraction left to right. This is going to give me 16 plus 33 minus 14. And this is going to give me 49 minus 14, which will ultimately result in 35, and 35 does in fact equal 35. This is true, and I have now checked my work as well. All right, let's look at questions 2 and 3. And the reason I say that is the directions tell us for 2 and 3, these rules apply. And these rules just say that PQS are collinear. And that just means they're on the same line. So if I trace them, I know that that line must equal 180 degrees. Do it that way. And it wants to know what is the measure of angle PQR. So again, to find angle PQR without worrying about the numbers yet, it means start at P, travel to Q, and then change directions at R, making Q your vertex. So from P to Q and Q to R is my angle PQR. So whatever is inside of that would be the value of PQR. And what it's given me is the expression 3x minus 6. So I'm just going to write that over here. Because what it looks like I'm going to be doing is solving for x in this problem so that I can substitute it in and get an actual measurement for it. And to do that, I need to look at what's going on in this problem. Well, I have ray QR here that is cutting through PQS. So what makes me think is if ray QR intersects angle PQS, then I have linear pairs, right? Because these two new angles added together will take me 180 degrees to get from P to S. So what this tells me is if I take RQS in green here, and I add it to PQR in red, I'll get my angle PQS, which is a straight line at 180 degrees. And what that will look like is, well, I've got red. So I'm just going to kind of highlight this area. So everything inside of this angle can be added to everything inside my green angle. And that would have to come out to what is inside of my black angle. So let's hope my color choices have not hurt me too much here. Let's go with this blue. So since they're linear pairs, I know that red plus green must add up to 180. And let's do that. So in green, I have x plus 2. In red, I have 3x minus 6. And PQS is 180. I'm just going to write the angles on top so we can see where they're coming from. PQS is my straight angle or my straight line. RQS is my green. And PQS is my red. And I can say that if I add them together, the two the obtuse angle and the acute angle, I will get the straight angle. From here, it's just solved by algebra. The first thing I want to do is combine like terms. These two together, 3x plus x is going to be 4x. And make sure I take the sign with me. Negative 6 plus 2 becomes negative 4. And this is 180. So my new expression is 4x minus 4 equals 180. I'm going to go ahead and add 4 to both sides. This gives me 4x is equal to 184. And when I divide both sides by 4, I'll get x equals, because those will cancel, 184 divided by 4 is 46. So I know x is 46. But it's asking for the overall angle. Well, let's do that by saying, to find that, I need to look at what is the measure of PQR, which I have up here. And I just need to substitute in my 46 for x. So then I'll have 3 times 46 minus 6. This is going to give me 138 minus 6 for a total measure of 132 degrees. So that is question 2. The measure of angle PQR is 132 degrees. Now I do question 3. I'm going to save 2 pieces of information. I'm going to rewrite PQR is equal to 132 and the x is 46. To do that, I'm going to put PQR is 132 degrees and x equals 46. And now I can start problem 3. So now we're going to go to question 3 that has us adding a ray QT that bisects RQS. That's a lot of stuff happening there really quickly. So I'm going to grab my line tool really quick, and we're going to talk about a ray has a defined starting point, but it continues in one direction forever. And we do rays the same way that we look at any other line segment. It starts at Q and it moves on to T. Now bisects means it cuts it in half evenly. So evenly cuts something in half. Or cuts it into 2. And what that is being directed at is angle RQS. So I have to draw the ray QT in the middle of angle RQS. So I'm going to come back up and just re-identify RQS, which we've done in the previous problem. But since we have a fresh diagram, we're going to do it one more time. So I started at R, headed to Q, and then from Q, I head to S. And this new ray has to bisect this angle. So it starts at Q, and then I need to figure out how do I cut this in half. Well, here's one point. Here's one line that generates the angle. Here's one of the lines that generates the angle. So it needs to be perfectly in the middle of these two. Obviously, I can't draw it perfectly, but what I can do is come back in here and show that it's bisecting by showing my congruent angle markers, right? One mark means that the new angle T I can place anywhere along the line that I want, because this does continue forever. So it's free to pick where it lands. But now I've generated angle RQT and angle TQS. And I can say that they are equal to each other because QT bisected RQS. And I can kind of look here and see that I still have angle RQS overall, but I have this point T that now, or this ray that has point T that's now generated a bisection of the angle. So now what I can say is RQT is equal to TQS, or RQT plus TQS is equal to RQS. And again, here's the overall angle. Here are the two new angles that we generated by the bisecting line. So what I can say is RQT plus TQS is equal to RQS. And I happen to know that RQS is just equal to x plus 2. And since these are equal, I'm going to call them angles. I'm going to say y plus y, right? So I'm going to call this angle y and this angle y. And I'm using the same variable because they're equal to each other. And the fallout from this is simply y plus y is 2y is equal to 46, right? I'm bringing in my x equals 46 plus 2. And I can do this. And now that I know that y plus y is equal to 2y, and that's equal to the whole angle RQS, I can divide by 2. And I get my cancellation of the y's. And I get y equals 24. And I want to know what is one of the angles. Well, this one's 24 and this one's 24. So since they're equal, I can say 24. The other way I can look at this, which would be a little bit quicker, but like I've said in class a bunch, it would be criminal not to show you as many different ways to do it as possible and to not always show you the fastest way, because you get a better understanding of the concept when we do it this longer way, is to come back up here. Let me just erase this part. And here's our faster way. I know I have, let me do a new color. I know this angle has to cut these two, or this one in half, into two equal parts. And I can plug in my x plus 2 and get 46 plus 2. And I know the whole thing is 48. And since these two are equal, I can just do 48 divided by 2 and get 24. So in my blue here, I have the fast way. But here is the way that you'll fully get an understanding of the problem. All right, for number 4, we're given that points L, M, and N are collinear. So I'm just going to go ahead and draw a line, and I'm going to label those points before I do anything else. Now, the order that they're presented to you is the order that will appear on the line from left to right or right to left. Keep it in habit for now to do always left to right. And I'm only saying that because as you get more comfortable with these, you will have the freedom to do it because it will work out. But for the test upcoming and just while you're getting a hang of it all, keep everything in the order that it's presented in the problem to make sure you don't make any mistakes. And it says, and we're given LM is equal to 18. So if I come here and I mark LM, I know that that has to be 18 units. And I say units because it doesn't tell us if it's feet, inches, miles, or even years, right? There's a bunch of different things we can measure here. And then LN, let me put this guy in red. LN is 27. So I'm just going to come down to the line that I drew. I'm going to see that LN is 27. So let me mark that. And it wants to know what's a possibility for MN. That means I start here and I travel to N, and that's my unknown value. Now, I would say most of us can look at this picture right now and see that from L to M and M to N is possible to use the segment addition postulate. And the way it's drawn out, when I take this break here, I'm 18 units into the journey out of 27. So I could just do 27 minus 18 and get 9. And x equals 9. But let me illustrate that in a bit more of a way, but you definitely can fast forward the video if you've got that one from that setup. So I know by the segment addition postulate that red plus green is going to give me my purple. And I'm going to set that up now. Oh, that's the wrong color, purple. And what that's going to look like algebraically is simply 18 plus x is equal to 27. Subtract 18 from both sides, and I get x equals 9. So we got the same answer both ways, both are just as valid as the other. All right, so for this one, question number 5, we have ray BD bisects angle ABC. Before I look at anything else, I'm going to go ahead and draw that construction since I do not have it visibly given to me ahead of time. You can start with ray BD and then draw ABC around it, but I've chosen to start with ABC. And what I've done there is drawn ABC for us. And then I know that ray BD has to bisect it, so I've constructed ray BD to also be inside of the angle. And now I can move on to labeling the values of the angles on the inside. And to do that, I'm going to choose this color for DBC, and I need to show that it is equal to x plus 8. So if I start at D, travel to B, start at D, travel to B, and then to C. And do you see why I always trace this now? Started on the wrong side of the line, and that tipped me off after only one move that I was headed the wrong way. So make sure you label your points, label your angles, label your lines, and verify as you're going that you're setting it up properly. And then my next step is that I need to do measure of angle ABD here, and to set it equal to 2x minus 15. So here's A to B, B to D, so I'm inside here. That gives me 2x minus 15. Just going to highlight that again. And the ultimate question here is, what is the value of x? So I'm going to solve this one with the black ink, only because yellow is very hard for me to see. So if I look at this, all of ABC is this measure, right? So I'm just going to put this line here for the value of ABC. I don't know what it is. 2x minus 15 is in blue. I know that ABD plus DBC is going to give me ABC, but I've run into a problem here for the way we've typically been doing these, and that is I don't know what the value of ABC is, right? It's never given to me, so I cannot assume anything else here. You can only use what you're given. So now I have to think about, what do I do to prove this? Well, I do have something here in my directions, and this is why I highlighted it. It's in red. It says ray BD bisects ABC, so that I get angles DBC and ABD. And what that means to me is those angles that are created are equal to each other. So let me do that in their colors. Now let me do a green, a darker green. So if ray BD bisects ABC, this means it cuts everything in this side and this side into equal halves. So I can say this angle and this angle marker go together. And the nice thing about that is I no longer need to know what ABC's value is, because I know that I can find a balanced equation by doing angle ABD is equal to, by the word bisects, DBC. And DBC's value is x plus 8. So now I have set this up so that I had an overall angle ABC. It was cut in half by this ray BD, and I've shown that those new angles are congruent. And since I know they're congruent, I can set them equal to each other. And I can solve for x by adding 15 to both sides and subtracting x from both sides. 2 minus 1x is just x. Negative 15 plus 15 is canceled. Bring my equal sign down. X minus x cancels, and 8 plus 15 is 23. And it wants to know what is x, and we have that at 23, so C is our answer. How do we check this? Because we always want to do that if we have time. We're going to plug in x. So now I'm going to say 2 times 23 minus 15 is equal to 23 plus 8, right? This came from DBC, and this came from ABD. This gives me 46 minus 15 is equal to 31, and 31 is equal to 31. So we have done this properly, and that is how it checks out. So this question says, what is the distance between points F and G? Round to the nearest whole number. Distance clues me in that we're going to need the distance formula, and that is our distance is equal to x2 minus x1 squared plus y2 minus y1 squared. And then we're going to take the square root of that value. And so what I need to do here is assign what are my x1s, what are my x2s, what are my y1s, and what are my y2s. And to do that, I'm just going to recopy my points. And I'm going to write x1 over this one. And x2, y2 over this one. You can do it in either way. And that's just because we're finding the length between them and then squaring it. And just like length must always be positive, find the difference between 2 points and then squaring them will always result in a positive. And if that doesn't make perfect sense right away, it's just because the act of squaring something itself that is a real number will always be positive. So now I can make my substitutions. Where I see x1, I'm going to want 2, and where I see x2, I'm going to want 5. And then where I have y2, I'm going to want 16, and where I have y1, I want 11. And then I'm just going to go ahead and fill in the rest of the equation around it. And then we have to understand that the radical itself is an understood or implied grouping symbol. So I've added these parentheses here to make sure I follow PEMDAS. So inside of my parentheses, I have 5 minus 2, which will give me 3. And then inside this layer of parentheses, I have 16 minus 11, which will give me 5. Keep this squared. Throw my new implied parentheses on just for clarity. Inside of these new parentheses, I have 3 squared plus 5 squared. And to do that, since they don't have the same base, I have to go ahead and square it out. And I get 9 plus 25. My implied parentheses come back down with me. And because these are in parentheses, and this is why I did it up here on this step, I can't take the square root of these and end up at 3 and 5 again. I have to add them together first. And 9 plus 25 is 34. And the approximate value of the square root of 34 is 5.83 something. But since I only need the nearest whole number, I really just need the 5.8. And rounding that is just 6. So this is 6 units to travel from F to G approximately. That's our nearest whole value. So question 7 and 8, we're going to use that number line. Let me see. Oh, it just magically appeared, so that's good. I want to know what is Km plus Ik. So to do that, I'm going to highlight them just because it looks like they're not in the right order, but I'm going to see if they are, in fact, good candidates for our segment addition postulate. Km is right here. And let's do Ik in this green. To go from I to K is good to go. And now I can visually see that I to K can be added to Km because where Ik stops, Km starts. So I can find their lengths and then I can go from there. So to find the length of Ik, I'm going to travel 1, 2 units, or I can do 0 minus 2. Which will still give me 2. So there's 2 ways to do it. We can do the counting method, or we can show the work. So we have 2 units plus 1, 2. Or again, I can do for Km 2 minus 0's absolute value and get 2. So Km plus Ik is in fact 4. Now it wants to know what is the midpoint of the coordinate GK. What is the coordinate of the midpoint of GK? Sorry, thought I misread that. So I'm just going to highlight GK, start at G, travel to K after you turn on your highlighter. So to go from G to K, I want to know what the midpoint is. Well, the midpoint is just the average of the distance you had to travel. And the midpoint formula when you have a number line is only the x part. There's no y coordinate, so you can say the y's are 0, and 0 divided by 2 will give me 0. So that means I'm not going up and down, I'm only going left and right, so I'm only going to look at my left and right values. So that's my first x value plus my second x value divided by 2. So the value of g is -4, and the value of k is 0. Divide that by 2, and I get -4 over 2 is equal to -2. So my midpoint of that is in fact -2. And the other way we can look at this is if I move one forward from G towards K and then one backwards from K towards G, and I keep doing that, if in the same number of steps, so this is step 1, this is step 2, they land on the same point, that is the midpoint. This way is not safe. It's easier, but it's not safe. If I asked for the midpoint, let me not use the same color. Actually, let me just erase all this, and then we're going to do one more problem I'm going to add right now just to emphasize why you do not want to do. What if I ask you for the midpoint of GL? Well, that means I start at G and I travel to L, so I can do 1 towards L, starting at L, 1 towards G. Do that, and now I have this bridge here. So then that becomes a problem. Some of you are going to say, well, no, I still know what it is. It's still the average between those two, but let's try it mathematically to prove it. We're going to have LG is the coordinate of L plus the coordinate of G divided by 2. It's going to give me -3 over 2, which is just -1.5, which is the average between -1 and -2. So it still works to do that method, but it's not as safe. All right, so for this set of problems, we need to use the conditional that they've given us and solve for 9, 10, and 11. And number 9 says, which is the conclusion of the conditional? So we're going to start up here. Anything from if to then is the hypothesis, and everything after then is the conclusion. So we just need to see which one of these options says a number is a whole number and an integer. And is inclusive. It must be both a whole number and an integer. So this one isn't inclusive. We're missing the whole number part. So we're not doing A. B, a number is either. This messes that up. Either means or. And our hypothesis, our conclusion has and in it. So we have to be careful there. Cannot be B. A number is both a whole number and an integer. That looks like it's going to be our best bet so far. And then looking at D, that's just our hypothesis. So we are good to go for C. A number is both. That's what and means. A whole number and an integer. Now let's look at number 10, which is the hypothesis. We'll highlight that in green really quick. If a number is positive, and if I look here, D says a number is positive. Now let's talk about why the other ones don't work. A number is an integer. Being positive has nothing to do with integers. A number is both a whole number and an integer. That's just our conclusion. And a number is either. That's just our conclusion misstated. So then the answer is, in fact, for sure, option D, a number is positive. Number 11 will not be on any form of the test. We have better ways to assess your understanding of these. This one's a bit complicated, so I will let you know This will not be on the test in this video. And up next we have question 12. What is the length of a segment with endpoints at -3 and 4? So I'm just going to rewrite those points here so that I can label them x1, x2, y1, y2, just to make this easier. So here's xy, here's xy, and I'm going to label this 1, 1, and this 1, 2, 2. And then I'm going to write out my distance formula again. Again, that'll be on the board for you during your exam. And that is x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And now I can just make my substitutions. x1 is -3. So I'm going to put that in parentheses just to make sure I protect this negative sign and don't get any confusion. And my x2 is 4. I'm going to put that in the parentheses that it started with. I'm also going to, so I don't make any mistakes, write in my implied parentheses overall. Then I'm going to move into what is my y2. Well, that is 4. And my y1 is also 4. And I'm going to keep those in the parentheses. And now I'm going to go back and fill out the rest of the equation. There is my protected minus sign so that I don't confuse it with a -3 and accidentally make that +3. I mean -3 when it should be +3. So now a negative and a negative being subtracted just becomes 4 plus 3 all squared plus 4 minus 4 is 0 squared. And I maintain this as well as my extra parenthesis. 4 plus 3 is 7 squared. And the 0 squared is just 0. And this gives me the square root of 49 plus 0, which is just the square root of 49, which gives me 7. Number 13 wants to know if the converse of the conditional is true. So the first thing I'm going to do here is, just for our sake, draw a truth table out, which will also be available to you during the test. And I know that if we have P, true, true, false, false, then here I get true, false, false. And then the P implied Q column is always in that manner. And that's just a quick setup since we have it memorized. And now what we need to do is recognize that this is in the form of P implies Q, and our converse is in the form Q implies P. So I'm going to identify my P and my Q, and then I'm going to swap their order. So my P is if a polygon is a triangle, and my conclusion is then it has exactly 3 sides. And what I need to do here is now switch their order so that I have my Q first, followed by my P. And let's hope I made those long enough. So now I need Q first, so it says if a call that a polygon, has 3 sides, then it is a triangle. So is there any way that I can arrange 3 lines so that all of their endpoints touch and it's closed, right? So each one of these must touch another piece and the shape that I draw must be closed. There's no way to draw this shape any way other than this. I also can't have it cave in, but that would still make it a polygon. So if a polygon has 3 sides and it is a triangle, is definitely true. All right, so which statements below are true? Select all that are true. I'm going to go on this one a little bit out of order. I want to start with C. And that's because we need to talk about our law of syllogism. And that just basically says if P implies Q is true, and Q implies R is true, then we can say P implies R is true. So think of P as you wake up. Q is you get ready for school. And R is you go to school. So this is saying you have P implies Q is true. So you wake up, so that's true. You get ready for school is true. And if you get ready for school is true, then you go to school is also true. Then you can just say that on days you wake up, you go to school. And that's exactly what we have here. We took our original hypothesis and came up with a conclusion, but we turned that conclusion into the next hypothesis, and then we got another statement that's true. So we can cut out the middle, kind of like our segment addition postulate, and say that P implies R is then true. Now if I look at D, I have P implies Q and just R are true. These events are not chained together, right? I would have to have Q implies R is true. So this one is false. Now I'm going to build a truth table to analyze this statement. What I want to do here is it says if P implies Q is true, I'm going to come over here and I'm just going to highlight only the parts where it tells me that P implies Q are true. And then notice this very important word here. That's and. So that means I'm only looking at cases when P implies Q are true and when Q is true. So let me pick this color and say for Q, I'm going to also say it has to be true. Then I can draw the conclusion that P is true. So let's do that one in green. Let me mark this one first just so we follow it along on the chart. So then P is true. So right now I'm not making any judgments or truth value judgments. I'm just going to come in and say P is true. That's here and that's here. But what I can see here is that P implies Q and Q are true in two different instances. Right? It's true here. Or let's just say this. My entire hypothesis is true in this instance as well as this instance. But is our conclusion true here? It is not. So it is not always true. It can say sometimes true, and that would be correct. But since this one is true, 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 it does work here. So that's an overall true. But here, if I then take this as all of this is P and this is Q, if I look at this truth table, let's call this scenario 1 and scenario 2. I think looking at a separate truth table makes it actually easier. So for scenario 1, my hypothesis in this brown box is true. My conclusion that P is true. And by truth table, that is true. But in scenario 2, again, my hypothesis that P implies Q and Q are true, so those check out. So I can say true here. But my conclusion is false. And anytime I have true, false, P implies Q is false. So I cannot say this is always true. And that is scenario 2 is our counter example. Now let me erase back and we'll look at B. All right, for B, It says P implies Q and P are true. So let's highlight that. So P implies Q is true. And P itself is true. So I'm only going to highlight when P is true. Then Q is true. So I'm going to come in for Q. I'm only going to highlight my Q column. And now I can look at this and say, every time P implies Q and P are true, I'm going to put that in a box that is brown, only because that lets me know P implies Q. Let me not put it all the way up there. For just scenario 1 here, P implies Q and P are true here. Here they're true, but this part's false and this part's false, so I can't put those in a box. Because these are not in a box, I'm not going to consider them because they haven't satisfied my hypothesis. So I'm not actually looking up. So the only thing I have here is scenario 1 to make a truth value about. I'm going to come down here and say that P implies Q. And I'm going to go ahead and start with scenario 1. So my hypothesis again was P implies Q and P are true. Double check it. P implies Q is true. P is true. So I'm going to say my hypothesis is true. And then Q is true. Well, in this scenario, Q is true. And true gives me an overall truth value of true. So that's true. But some of us might be looking at this right here and say, why wouldn't we do this? Well, let's call both of these together scenario 2. In scenario 2, if P implies Q is true, that's good to go. But here's the problem. Our hypothesis is false. And remember, right, P is not true here. It's actually false. So here we would have a hypothesis for this conditional that it is false, even though in this instance, Q is true. But remember, anytime we have false hypothesis, we automatically jump on to say true. But we didn't meet the conditions, so we're not even concerned with scenario 2 in this experiment. But I am just showing you why it doesn't work for this question. So our final answer is false, true, true, false. All right, here's the law of detachment. This is the form of logic you guys are much more likely to have been using your whole life. Just saying if there's a certain set of conditions, how does the world work under those conditions? And what we have here is if a person wants to get a car, then that person must buy car insurance. And the tricky part here is we can't read in more information than what we're given. This is a hypothetical situation. So Jayla wants to get a car. So we know to get a car, you must have car insurance. We don't know anything else about the requirements to get a car in this scenario. So it wants us to know which one of these is true by the law of detachment. And the law of detachment simply means you can only use what you're given. Do not bring any of your personal knowledge into the problem. So a person wants to get a car. Jayla wants to get a car. So what must Jayla do? She must get car insurance. Does this tell us that she has car insurance though? No, just that she wants to get a car. It did not tell us that she has car insurance. Jayla has her driver's license. Now, a lot of times people will say, well, yeah, you have to have a driver's license to get a car. But in this problem, it doesn't tell us that. She may live in a country where the driver's license rules aren't there and you only need car insurance. And as long as you're insured, you can drive. It could just be the condition that that's the only thing left for Jayla to do. So her parents are only reminding her of that. No reason to keep telling you everything you've already accomplished towards your goal. But your last goal may be just to buy the car insurance. So Jayla having her driver's license is ruled out. Jayla must get her driver's license. Well, this problem says nothing about that at all. Jayla could be 4 years old and just want a car. And then her parents are telling her the only thing stopping her is you must buy your own car insurance. we'll buy you the car. There's a lot of things, but see, even when I say that, I'm reading into it, and why I'm doing that is saying I'm trying to get you guys to catch your thoughts here about how you're adding extraneous or outside information that's not given. And then our last one says Jayla must buy car insurance. This is really the only thing we can conclude from this. We know that she wants to get a car. In order to get a car, she must have car insurance. So D would be our correct choice. All right, if you're struggling with number 16, I will let you know on the test. This will be a drop-down menu, and you have a choice between theorems to choose from. So I'm just going to talk about how we would determine which theorem it is. All we're given is that angle 2 is congruent to angle 4, so I'm going to put my angle markers here. And I know that the linear pairs theorem tells me that angle 2 plus angle 1 is 180, and angle 3 plus angle 2 is 180. So that doesn't do anything for us. So linear pairs is out. Now, I have two lines that are intersecting, and anytime I see that, the first thing that comes to mind is linear pairs or the vertical angle theorem. The vertical angle theorem just says when two lines cross, angles on the opposite sides are equal. So the one on the left and the right are equal. The one on the top and the bottom are equal. So I can say T is equal to B and L is equal to R, which is exactly what it's saying in this. The top is equal to the bottom. So I'm going to put vertical angles theorem for this question. For the next one, it says if the measure of angle 1 equals 4x plus 2, so I'm going to fill that in. Right? That's my hypothesis, so I have to start with that. And the measure of angle 2 is equal to 110. What is the value of x? Well, we just talked about the linear pairs, and we just said angle 1 plus angle 2 has to add up to 180. And now I know what angle 1 and angle 2 are. This is angle 1, and angle 2 is 110, and together they must add up to 180. Do the algebra. 4x plus 2 is equal to 70. Continue the algebra. Now I can divide by 4, and I know 4 times 15 would give me 60, and I need 2 more. So x is 17. Now for number 18, it says, which could be the first step of an indirect proof of the conditional below? So it wants me to turn this conditional into a proof. This means I can automatically rule these two out because they're just more conditionals. This is like answering that question with another question. So to do an indirect proof, we always start with we assume. And only A and B start with the word assume. So that's a great sign that we're doing it correctly. And we're down to 2 options. Now we have to think about what are our valid forms of indirect proof that we've learned in this class. Right now I've asked you to only work on these 2 for indirect proof. We've also worked on direct proof. And that's just where you turn the conditional to a proof with no change. So if I look at A, it says assume x equals 9, which is exactly what we started with originally. Then x, 81 equals x squared. That's exactly the conditional we started with. So this would be done by direct proof. And now that I'm down to one answer and I've made sense of these, I can be confident that these are correct. But if I want to leave class knowing I got it right, I'm going to analyze this proof, this first step, to see if it matches either the converse or the contrapositive. If I have my P as x equals 9 and my Q as 81 equals x squared, then I just have to flip them for the converse, which is just QP, what we did earlier in the video. This would tell me 81 equals x squared and x equals 9. that doesn't work because the signs went from positive to equals to not equals. So the contrapositive is flip it and negate it. So now I'm going to have not Q and not P. Not Q looks like 81 does not equal x squared, and not P looks like 9 does not equal x, which is exactly what we have, except for I did 9 equals x, so it should be x does not equal 9. But those are equivalent statements either way, so we're good. So that is how we would check that. And since contrapositive is what B is, and it starts with assume, that is our first step in a proof, indirect proof by contrapositive. All right, so I can't show you the test in class, but this is form B pulled up. Here's question number 19 and 20. This part is 19, this part is 20. Impossible to put drop-down menus on a sheet of paper, so when I make this on paper, I have to get rid of this part and I just leave the blanks. And basically what it's saying is you're given this statement and it wants you to construct the contrapositive. So that means I'm going to switch the order of Q and P, and I'm also going to negate them. So I'm going to identify P first, and then Q is everything after the word then. And here, to get the contrapositive, I have to say not Q implies not P. So it says if a person, well, actually probably be easier to just do the drop downs. So if my Q is that person is Neil Armstrong, the contrapositive would put this first and say if a person, and I have to negate it because I have not Q, was not Neil Armstrong, then that person, if a person was the first, would be was not the first person to walk on the moon. Since Neil Armstrong was the first astronaut to walk on the moon, the contrapositive is true, right? If a person was not Neil Armstrong, then that person was not the first person to walk on the moon. I am not Neil Armstrong, and I was not the first person to walk on the moon. So that's true. Since the contrapositive is true, right, it should match this answer, because what it wants you to do is tell it that the truth value for the original conditional and the contrapositive are always the same. And you can see that I got that one correct. All right, that's the review. If you have any more questions, message me.